And I enjoy puzzling over these big questions, so I hope you're going to enjoy today puzzling through them a little bit with me. Okay, so you've got green cards and red cards. Just out of interest, how many science enthusiasts have we got here at the moment? How many people either planning a career in science, possibly thinking of a career in science? Spot the science teachers. Excellent. How many? Come on, green cards or red cards? Red cards if you're not, if you're heading definitely towards the humanities. Green cards if you're heading towards the sciences. And flicking if you are probably going to be trying to combine the two of them. So we've got maybe a couple of people over there thinking they're going to, maybe three people are going to combine, four people going to combine. Cards up, how can I count? Okay, we've got a really good number, good proportion of scientists in the room, which is excellent, and a good proportion of humanities as well, and arts. Lovely, okay. Well, I like bridging questions. I like questions that puzzle us about both the sciences and the humanities at the same time. And I'm going to persuade you that these questions, for example, are good examples of that. So science might help us to answer these questions, but it can't always fully answer them. And that will be a bit of a theme today. We'll be thinking about how far science can take us and whether we actually need other ways of thinking to get us the rest of the way. I'm really interested, and we are at Reading in general, in multidisciplinary thinking. So we put together big teams of scholars from different disciplines to work together on big questions. Now, sometimes when I try and go forward, I end this. Okay, are we at the University of Reading? This is test your cards out. All right, are we at the University of Reading? Anybody who thinks we're not is in the wrong place, so that's fine. You're welcome anyway. Excellent. All right. Will we travel faster than light in the next 200 years? Will we travel faster than light? Oh, we pretty much all know. We've got maybe one. Oh, and the yeses are changing their mind in light of all the no's. I think we've got one yes here. Okay, why no? Why do you think no? Why do you think no?
It's not really possible.
Not really possible. Do you agree not possible, or is it just a matter of time?
Anything is possible.
Anything is possible. Okay. Who thought yes? Somebody along here. You thought yes, didn't you? I'm sure. No, you're looking all round. He thought yes, didn't he? I saw your green card. Why did you think yes? Even if you're changing your mind now. Why did you think yes?
There's a lot of time.
Lot of time. 200 years is a long time. Excellent. We just welcomed back. Who? Who have we just welcomed back to Earth? Tim Peake. Brilliant. Have you been watching in the news? So Tim Peake has been in orbit. What's the furthest so far humans have been? The moon. Excellent. If you were to go to the moon at light speed, how long would it take you to get there?
2 seconds.
Very good. About 2 seconds to get to the moon. 2 seconds. All right. How long does it take light to come to us from the sun?
8 minutes.
8 minutes. Brilliant. What about the next nearest star? 4 years. That's right. I heard it. 4 years. 4 light. Okay, so light at light speed. 4 years to the next nearest star. And we've been how far? 2 seconds. We've been 2 seconds. We've got a lot of universe left, haven't we? A lot of universe still to explore. Even if we headed to the next nearest star after the sun, that's 4 years. How far across the galaxy? Does anyone know? How many light years across the galaxy? Oh, I reckon. Oh, yes, at the back. Go on, Martin. 2 million? That's enormous. Excellent. There you are. There's a question to take away with you. Can we answer that question scientifically, do you think? How far across the galaxy it is in light years? Can we answer that scientifically? Oh, you're not sure? Green cards if you think we can, red cards if you think we can't. Can we answer that question scientifically? How do we go about trying to answer that question? Okay, so we've got some greens and some people not quite sure. Okay, and a couple of reds. Very interesting. Very interesting. All right, does science and religion fit together? What do you think? Green cards, yes. Red cards, no. Does science and religion fit together? Be brave. Stick your cards up. Up. Let's see. Okay, so I think we've probably got more greens and a few reds. Very, very interesting. Okay. Because I like questions that puzzle the mind, I really love optical illusions. What about this one? How do you think this is done? Can you see why it's an optical illusion, first of all? What's strange about it? Does it make sense? Does it look real? How do you think it's done? Think pair share with a neighbour. How do you think it's done? Can you see what's strange about it? And can you think how it's done? Okay, who's got an idea they can share with their friend? Who came up with something interesting? Do you know where it is? It's a real object. Where is it? It's in Australia. So it's a real object and it's in Australia. How is it done? How could you find out? What could you do to try and find out how this optical illusion works? What would you do? What's the problem with seeing it right now, like this? One angle. You've only got one angle, haven't you? You're only looking at it from one angle. What might help? Look at some more angles, that's right. More observations. Very important in science, observations. We're as good as our observations. Okay, so let's see what happens if indeed we can move around it. There you go. That angle was all a big important factor there, wasn't it? Now we've moved around, you can see exactly how it's done. And I love the idea that we might build a really big, odd-looking device just because it's going to look really strange when we look at it from the wrong angle. Do you like that? It's cool, isn't it? My other all-time favourite optical illusion. Tile A is exactly the same shade of grey as tile B. Green cards if you believe me, red cards if you think I'm making it up. They're exactly the same shade of grey. If I put tile A on top of tile B, you'd see that they were exactly the same colour. Quite a lot of people believe me. Very interesting. Is that because the science teacher's usually right? Or because you've seen it before? Why do you believe me? Let's see. Who's going to volunteer? What about you? Why do you think I'm right?
Just because you said it.
Just because I said it. And the last optical illusion turned out to be right, didn't it? There was something behind it. How could you test it out? What could you do? Suppose you had it on a piece of paper in front of you right now. How could you check out whether slide A and slide B really are exactly the same shade of grey? What could you do? Think pair share. What would you like to do? So the other one we walked around. What would we like to do with this one? I heard somebody come up with a good idea. How would you check it out? What's about up there at the back? What do you think? Yeah, someone up here. Ideas? This row, this row? How would you check it out? Say again?
Put them next to each other.
Yeah, put them next to each other. Very good. Yep, or cut them out. I heard someone say, cut them out. So the wonderful thing about PowerPoint is we can cut them out, okay? And then the other wonderful thing is that you will find this online as well. So if you want to have a go with it yourself, you can have a look. Okay, so I have cut out slide A, and I am going to move slide A onto slide B. Ready? You like that? Believe me now, right? Let's move back. Ready? Yes, yes. You can start to think about why it works now as well. There you are. So what's fooling you in this case? Yeah, so you're seeing the shading of the barrel. Be interesting if we could take the barrel out, wouldn't it? Then we can see if it looks completely different. Okay, so in that one we could also test something out and make observations. So it's good when we can test an idea out and make observations, isn't it? All right, This is going to be interesting. So what I'm going to do is I want to find out how many students are on each row. But instead of just counting them, I'd like you to clap. So you're going to clap, and that will be 1, okay? And then you will clap and say 2, and then you will clap and say 3, you will clap and say 4, 5, etc. All right? And we're going to see how many students are on each row that way. So the person on the end of each row will need to tell me how many students are on the row. You got it? Ready? Set? Go.
1.
And you'll need to go, right, all the rows. Okay, all the rows. Right. This is the difficult row. They've got a lot of people. Okay, you ready? All of you. And you'll need to clap, won't you? You'll need to clap. Yes, yes. You got it now? All right. I want to know how many people are on each row. Excellent. Are you ready? Go.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Right. Okay, on this row. 9. On this row. 8. 11. This row. This row? This row, 2? 2 students? This row, 4 students? That row? Yeah. Back row? 3. Lovely. Okay. If you wanted to be sure, what could you do? You could do it a different way. You could just count them. Excellent. What else could you do? What else could you do to confirm? Yes, okay, good. Anything else? Do it again. There you go. That was what I was waiting for. Brilliant. Do it again. Okay, do it again. Off you go.
4.
Excellent. Did everybody get the same answer as last time? Yes? So it's kind of handy when we can repeat something, isn't it? If we can repeat something, we've got a better chance of confirming that we're right. One of the questions I'm interested in thinking about today is whether we can always repeat things. Can we always repeat things to see whether the ideas that we've come up with are right? So in science, it's very important to repeat things to see if we're right. Who wants a robot? Green cards, yes. Red cards, no. Oh, quite a lot of no's. How very interesting. Excellent. All right, why no? Who said no? Who's going to tell me why no? Why no?
Because I don't want them to start controlling me.
Right, all right. Very interesting. Raises a lot of questions. Okay. Anybody else said no? So we don't want it to control you? Kill you? Gosh. These are some aggressive robots, all right. Anyone who said yes? Why yes? Make life easier? Yep. Any other reasons why yes? Did you say yes? You said no?
I said no.
Why did you say no?
I said no because the reason for being humans is because we do certain things, and if we give all our jobs to robots, then what are we doing? We're just, like in the pictures, we're just lounging on.
Getting lazy. Excellent. That is a big issue, is how would having slave robots make us behave? I agree. Okay. Could a robot learn to play music?
Yeah.
Green cards, yes? Okay, so we all think a robot could learn to play, nearly all. One person thinks no. Most people think yes, a robot could learn to play music. Would it like the music? Could it ever really like the music? Ooh, might not know. Excellent. More difficult to answer that question, isn't it? More difficult to answer that question scientifically, maybe? Is this love? It was in the newspapers not very long ago that this is love. You want to see this is love? Brain scan can detect whether or not you're in love. One of life's toughest questions to answer is, what is love? There it is. Brain scanned a lot of people, and that's love. If you agree that's love, put up your green card. If you think that's not love, put up your red card. If you're not sure, wave your card. Is that love? Would you like a brain scan to tell you whether you're in love? Green card, yes. Red card, no. Would you like a brain scan to tell you whether you're in love? More no's than yeses. Would you like a brain scan to tell you whether the person you hoped was in love with you was in love with you? quite a few reds again. Interesting. Could a brain scan tell you whether the person you were in love with or wanted to love you was in love with you? Would it work? Could you use that as a test? Think, pair, share, and then have a vote. Could you use a brain scan to find out whether somebody else is in love? What do you think?
I think you can, but the way it affects a person's thinking, that's different from like finding out whether the person is in love or not.
Interesting, very interesting. Very nice answer. Excellent. All right. So a lot more of these sorts of questions will be explored during the day. I think oh, there we are. And how would we know? Which was kind of a bit similar to what I just heard somebody saying. So how would you know, indeed? Okay. So just to summarise where we've got to. I've mentioned that today we're quite interested in how many of our questions we can answer scientifically, how far science can get us with answering some of these big questions, and what we might then need other ways of thinking to get us the rest of the way. And I've put this slide up as a kind of a good rough guide as to the sorts of questions that science can particularly help us with. So science is particularly good when we can observe, when we can repeat the observations, when we have something that we can make a prediction and then observe whether we're right, whether we can get all the different angles, so a good range of observations. Scientists always being ready to change their minds if a new observation comes along that means that the theory that they did have no longer seems to be holding true. And that's happened an awful lot of times in history. Right, well, you've been fantastic. Really well done. Give yourselves a clap. There you go. And I think when Zoe comes back in, Zoe, all right? Do you want to...
Yeah. Okay, so we're going to